All right, now we're going to be looking at finding the point of intersection between two circles. To find the point of intersection between two circles, we have to rewrite it from the general form to standard form. So looking at the first equation right here, this one, let's call it 1 and call it 2. All right, so we're going to call this equation 1. I'll call this one equation 2. If we're expanding equation 1, that is going to become x squared minus 4x, then minus 2 squared is plus 4. Then we have y minus 3 all squared, that works out to be plus y squared minus 6y plus minus 3 squared, that's now just plus 9, and that's equal to 9. So that's what we get right here. That's expanding the first one. Let's expand the equation of the second one. After we expand the equation of the second one, what we're going to get is x squared minus 2x plus 1. Then we expand this part, we get plus y squared minus 2. No, actually it's plus right here. So it's actually plus 2 times y. And then 1 squared is plus 1. And this is equal to 16. Now, after you expand the two of them and get it in general form, what you're going to do is subtract the two equations. You're going to subtract them. So equation 1 minus equation 2. X squared minus x squared, put a bracket around it so you don't make any mistake. X squared minus x squared, that becomes 0. Minus 4x minus 2x. Minus and minus become plus. Minus 4x minus 2x, that become minus 2x. Then 4 minus 1 become plus 3. Then y squared minus y squared gone. Minus 6y minus 2y, that become minus 8y. Then 9 minus 1, 9 minus 1 is 8. And then 9 minus, so then you have equal. And 9 minus 16 is, 9 minus 16 is negative 7. So now bring all the numbers to one side. Your 3 and your 8 is 11. That's 11. 3 plus 8 is 11. Yes, 11. Then we'll bring over the 11 to this side. Bring over the 11 to this side and we get minus 7 minus 11. That's minus 18. And we have minus 2x minus 8y minus 2x minus 8y equal negative 18. Of course, you can divide through by 2. Why would you want to be working with this? Divide through by 2 to get x plus 4y equal to minus 18 over minus 2 is 9. So x plus 4y equal 9. Now, what you've just found is the line of intersection between the two circles. This is the line of intersection between the two circles. Now, if you substitute the line of intersection into any one of these equations, you get the point of intersection. So what I want us to substitute is make x the subject from here. Making x the subject, we get x is equal to 9 minus 4y. X is 9 minus 4y. And so we plug x as 9 minus 4y into any one, either equation 1 or equation 2. So let's plug it in equation, let's say equation 1. If we plug it in equation 1, what we're going to be getting is x minus 2 squared. So it's going to be x, replace x with 9. It's going to be 9 minus 4y minus 2 all square plus, or just right back for y minus 3 all square, and this is equal to 9. I plugged it in equation 1. You could have plugged it in equation 2. And you didn't have to plug it in this form. You could have plugged it in this as well, because this is the same general form. All right. So what we end up getting now is 9 minus 2 is 7. So what you get is 7 minus 4y. And this is all square. 7 minus 4y all square plus y minus 3 all square, and that is equal to 9 plus y minus 3 all square equal to 9. Then what do? Expand this square now. So it's first term square. 7 square is 49. First term square minus twice the product of the 2. So it's minus 2 times 7 times minus 4. That is minus 56. Is minus 56y plus second term square plus 4y square. 4y square is 16y square. 16y square. Then we have plus y minus 3 all square is y square minus 6y plus 9, and that's equal to 9. Nice. So what we're getting is the 16 square and the 16y square and y square, that works out to be 17y square. 17y square. Then we have minus 56y minus 6y, so minus 56y minus 6y, that is minus 62y. It's minus 62y. And then we have 49. Let's see, 49. And we have 9 here. So 49 plus 9. Then bring it over to the other side. Bring the 9 over here rather. So we subtract 9. So we end up get y squared minus 62y plus 49 is equal to 0. Wow. Now this looks incredibly hard to factorize. So let's check to make sure I didn't make any error. 9 minus 4y. Yes. Replace x with 9 minus 4y. It's 9 minus 2 is 7. 7 squared is 49. 2 times 7 is 14. 14 times 4 is 56. 16y squared minus 6y plus 9 equal 9. So no error was made. But this is what we have. So of course, we're just going to use quadratic formula. Use quadratic formula to solve this. All right, so we're going to use quadratic formula to solve this one. All right, so using quadratic formula, we're going to get y is equal to minus b, which is 62, plus or minus the square root of b squared minus 4ac, which is 62 squared minus 4 times 17 times 49. Just using some quadratic formula here. And so when I work this out, what we are getting, then divide it by 2 times a, which is 2 times 17, which is 34. So we get two values for y. I'm just going to put it in the calculator. 16 plus or minus the square root of 62 square minus 4 times 17 times 49. So one answer is 2.5. So I get one answer is 2.5. This is one answer. Or the next y value is 1.2. We get 2.5 or 1.2. If this is the value for y, then the corresponding value for x is plug 2.5 in this equation. Remember, this is the x formula. So it's going to be 9 minus 4 times 2.5. So I get -1 here. So I get one answer for x is -1. And next answer I get right here, plug 1.2. 9 minus 4 times 1.2. I get 4.2. 4.2. So that's how we find the point of intersection. So to put them as a coordinates, so the points of intersection are, the intersecting points are -1, 2.5. And the next one is 1.2, 4.2. That's it. That's it. So intersection points, -1, 2.5, 1.2, 4.2. So that's that. That's how we find our points of intersection. Now, of course, I'm going to verify everything using the graph. So we're going to look at the graph right here. It's always good when you see it graphically. So we're going to sketch the first circle and the second circle, right? So we're going to put these circle on the graph. It's always good when we can see it. So look at this circle right here. So the first circle is x minus 2 all square plus y minus 3 all square equal 9. So the radius is 3 and the center is 2, 3. So let's do that. So of course we go to rectangular grid. And first thing we want to make sure is we don't want a decimal place. Units. The center is 2, 3, radius 3. So this is 1, 2, this is 2, this is 3. Center is 2, 3, and radius of 3. 1, 2, 3. This is the first circle. This is the first circle right here. So that's the first circle. Now let's find the equation of the second circle. The second circle given was x minus 1 plus y plus 1 all square equals 16. So that has center 1 minus 1. So center 1 minus 1 is this. Center 1 minus 1 is here. And it have a radius of 4. So that's 1, 2, 3, and 4. This is it. Did I get this right? 1 minus 1. Just need to make sure it's right. 1 minus 1, radius 4. 2, 3, radius 9. Did I get both of those right? 2, 3, 2, 3, radius 3. 1, 2, 3. Then minus 1, 2, 3, 4. Yes, this is right. So these are the 2 points of intersection. So I'm going to label these points now. Hiding these points. Oh, we actually want the to 1 decimal place. So I'm going to change it back to tenths. We want things in 1 decimal place. So look at this now. The points of intersection of the 2 circles are here and right here. So what's the coordinate of this one? I want the coordinate. Wait, this is the wrong circle. Center is, what was the center? 1 minus 1. This is not 1 minus 1. I sketched this circle wrong. So let me hide this circle. My apologies, that center, that was circled wrong. 1 minus 1 is not right there. 1 minus 1 is not right there. Let's go again. The center was 1 minus 1. 1 is here. This is x is 1, y is minus 1 here. And the radius is 4. 1, 2, 3, and the 4. This is what we have. So now I can label the points of intersection. Points of intersection are here and here. All right, we don't need nothing else. Need to hide that. So these are the two intersecting points. So let's find the coordinates. So see there, this coordinate is 4.4, 1.1. Did we get that? And then this point is, I want to show the coordinates. -1, 2.5. So -1, 2.5 and 4.4, 1.1. Did we get that? -1, -1, 2. Yes, we got the -1, 2.5. And because I rounded off earlier, so it's slightly not 100% accurate. I got 1.2, 4.2, and it's because I rounded off. It should have been 1.1, 4.1, but definitely got, oh, I even wrote it the other way around. This coordinate needs to fix. I wrote it wrong. X value is 4.2, comma 1.2. But as you can see, I wrote it wrong because I did some rounded off right here. That's why I didn't get the exact 4.1 and the exact 1.1. All right, but this is the exact solution for the graph. It should have been 4.4, 1.1, and -1, 2.5. I got the -1, 2.5. I got that pretty accurate, -1, 2.5. But this part, 4.4, 1.1, because I rounded off, it affected the values. But that's how we find point of intersection of a circle. So again, you have to remember to find point of intersection of a circle. First thing you do is you find the line of intersection. Before you can find the line of intersection, make sure they're in their general form. Put it in its general form, and then you subtract the two equations to find the line of intersection. I'm going to show you the line of intersection right here. So if you look closely, if I were to draw this line, so look at this, x plus 4y equal 9. If I were to make y the subject, that would be telling me y is equal to, this is 9 minus x over 4. Y would be 9 minus x over 4. Now, if I were to draw the line 9 minus x over 4, look what happened. I'm going to show you what happened. The line 9 minus x over 4. 9 minus x divided by 4. If I plot that, look what happened. That's the line that passes through the 2 points of intersection. So when you solve a circle, when you solve two circles simultaneously, you first subtract one equation of a circle from another to get the line of intersection of the two circles. Then you substitute the line of intersection into any one of those two circles. That's what we do. Nice. All right, let's look.